Hello all, I hope you are doing good. So I think most of them participated in this Leetcode contest. So let's solve this problem, like make cost of path equal in binary tree. So let's first understand this problem. So here you have given an integer n representing the nodes till 1 to n, and there is a node 1 and each node I in the tree has two children, where the left child is 2 into I and the right child is 2 into I plus 1. So let's understand what is a perfect binary tree. So perfect binary tree is such that every node other than the leaf node should have two children. Suppose if you take this 1, 2, 3, 4, 5. Now these leaf nodes have 0 children, and this node has two children, and this node is not a leaf node, but it don't have any children, so we can say it is not a perfect balanced tree, perfect binary tree. So if it has 1 3 6, still it is not a perfect binary tree. If it has 7, then we can say that it is a perfect binary tree. So I think you got what is perfect binary tree understanding. So let's understand the problem, what problem states. So in the problem, each node in the tree also has a cost represented by a zero indexed integer or a cost of size n. So for every node you have given some cost, and this node starts from 1. So don't make it mistake, like in the array it will start from 0, but here it is starting from the 1, and we need to return the minimum number of increments you need to make the cost of path from root to each leaf node equal. So it states that from here, suppose you are going from here, from root node to leaf node, this sum and this sum and this sum and this sum, this all needs to be equal. It's stating that, and we need to make them equal in minimum number of steps. So let's understand the problem more clearly using this example. So I have constructed it like this: 1 2 3 4 5 6 7 8. This is the construction, and these are our values. So let's see, like 1 5 2. What is the sum? Here the sum is 7 8, sorry. Here the sum is 8. Here the sum is 6, and here the sum is 4. So we need to make all this equal. So all this equal. So first thing what we will get in the mind, we will think like, okay, let's make this now the sorry, this is 9. What we will think, we will make this as 9, and this as 9, and this as 9. So this is the best thing we can do, like this is 9, so 9 9 9. So what we'll think, okay, let's see like this. What we'll do, we will make all the base elements equal, so that all the base element, will try to make all the base elements equal, all the base elements equal. Then we'll think we will get to the minimum answer. So let's see, it is 9. So here the maximum value is 3. So what we'll try to make, we'll make this 2 as 3. So here it will take one step, and for this 3, now it is 3, there is no steps. For this 3 it is 1, so 2 step. At this step we are making 3 change. And what we will think now, 5 2. Here we should make it as 5, so that all the values will be equal. So we will make 3 steps, it is 6. So in this test case, if you see that output is 6 and it is matching. But if you see it clearly, like suppose we take this test case, now here the sum is 9, sorry, it's 10, it's 10, and here it is 11, and 6 and 7. So if you try to make all the values to 5, let's see, let's make this 5, we need to add 1, and here we need to add 3, and here we need to add 2. So what we will get? 6. And if we need to make 5 and 5, this 3 as 5, let's add 2. What we will get? 2. Total sum is 8. But if you observe clearly, let's 1, 5, 3, 4, 5, 2, and 3. If you observe it clearly, we are adding, now we are adding this 3 and 2 over here. But and we are adding 2, we will making this 3 to 5 here. So if you think in this way, let's see like what exactly it is showing. Now the sum is here 9, here it is 10, here it is 6, here it is 7. Now if you make these two equal, so here we are taking one step, and if we make these two equal, here we are taking one step. So how many total steps? 2. Now we are returning it. Now here the sum will be 10, here the sum will be 6. Now if you make it as 4, suppose if you increment this as 4, then it will be equals to 10. 4. Total number of steps are 6. From this what we understood is that if we increment the leaf nodes like child nodes, we will increment it into 2 times. But if we increment the parent node, we can increment only once. So in this way we can think like for each node, for each parent node, and there are 2 childs, we should make this both childs equal, because it will go up and it is completely dependent on this parent node. Suppose if we don't make this both equal, then we will not get the sum as equal from if we calculate from the root node. So the first step is that we should make all the root nodes, like all the root nodes which are adjacent to each other and which has the same parent to equal, and in this way we can solve this problem in the minimum number of steps. I think you have understood the approach. So let's see like how we can solve this. See the number of solutions I could not really make in the contest because I made a silly mistake. So let's see. So, suppose he is given 7. So what we can do, if we given 7, we have nodes 1, 2, 3, 4, 5, 6, 7. We need to compare 4 and 5, 6 and 7. So what we can do, if n is 7, we need to calculate 2 power n minus 1 is equals to 7. So 2 power n is equals to 8 and n will be 3. N will be 3 and n will be 3. So n we are got 3 and we need to iterate from 2 power n minus 1 to 2 power n minus 1. This is 4 to 7. So first we need to calculate the power of n. See how we need to I will show you the code how we will calculate. So we will take s is equals to 1 and we will multiply s 2 times and then we will increment k. We are incrementing the k. Here we are getting, if suppose n is 15 and we will get k as 4. But what we should do, we should iterate from 8 to 15. So 2 power k minus 1 to 2 power k minus 1. You understood the difference? We need to iterate from here. We are iterating and we are calculating the power like 2 power I. So 2 power I, suppose 2 power I means it's 7, it's 8. If n is 15, then k is equals to 8 to 15 in the beginning, in the first step. So we will take 8 and 9, and whether we will check like if a is less than b, we will swap, and we will add the answer. We are making every leaf node equal, so we are adding this answer, and we need to return it to the parent. Like if you see this example, 1 5 3 4, if you see this 1 5 3 4 5 2 3, we are making this equal. So here we are getting answer 1, and we are return 5. Only one time we are returning, so it is becoming plus 5. Here we are making it 3 3, and we are returning 3, and it's becoming plus 3, and then we will make this equal, and here we will get plus 4. So in this way we are swapping it, and we are returning it, and finally we are returning the answer. So I think most of them understood the approach, and this was a pretty easy problem, but couldn't able to solve in the contest. So, and let's see the what will be the time complexity. So total k, so in what is given in n is 10 power 5, so 2 power k is equals to 10 power 5, and it will go like k is equals to 20. So 20 into, and we are iterating each time like n times. You can see that from in the beginning, suppose n is 15. In the beginning we are iterating from 8 to 15, then 4 to 7, and 2 to 3. How many times we are iterating? Only n times, so n. So we can say that 20 into 10, order of n. We can conclude that time complexity as order of n, and the space complexity would be same order of n. So thank you guys.